Hello, everyone. Thank you for joining us today. We're just seeing a lot of attendees rolling in right now. If you don't mind, we're just going to wait 1 minute before we kick things off. All right, let's get this party started. Thank you so much, everyone, and welcome to Origin and Cause's webinar titled Under the Weather, Getting to the Root Cause of Wind and Snow Damage. Sorry, I'm just trying to click here. Okay, great, it worked. So welcome again, and I hope you guys are all keeping well, in good health, and in safety. I'm glad you made it out and joined us for our first webinar of the year. I wanted to go through a couple of quick points with you first. We're going to be doing a live Q&A at the end of the webinar, so please feel free to submit your questions through the text box that you see there in your webinar screen. We're gonna try to get to as many questions as possible within the hour. So if we don't get to your question within the webinar time, we promise to follow up with you after the webinar to make sure your questions are answered. And all the questions submitted will be anonymously addressed. Quick disclaimer, all information discussed in this webinar is for educational purposes only and should not be applied directly to the administration of any particular file or claim. Obviously, there's so many ways, so many scenarios that these claims come in, and we encourage you to give us a call so we can discuss that particular file and be able to guide you with the principles that are taught in this webinar. Also, the webinar is being recorded and will be posted on our website, LinkedIn, and YouTube pages, so please feel free to pass them on to your colleagues. We're going to be sending completion certificates by email within the next few days. And as mentioned in our communications, this is a repeated webinar. So make sure that if you're looking for continued education credits that you haven't already applied for this course number in the past. Some people don't need continuing education credits and are just tuning in because it's great value, great content, and great things to learn. So we welcome you all. At the end of the webinar, when you close the GoToWebinar, the program is going to prompt you to answer a few questions about the webinar. What do you think of the feedback, ranking the speakers, the content? Also, we're going to be announcing at the very end of the webinar our next webinar topic, and in the questionnaire that that will prop up on your screen, it'll give you the opportunity to sign up to the next webinar. So if you want to sign up, you can click that button and we'll make sure we'll get you on that list. If you're experiencing any technical difficulties throughout the webinar, please email our team at webinar@origin-and-cause.com. Okay, let's get started. I want to introduce our speakers to you. First, we have Nabi Guderzi. He's based in our Ottawa office. He's a professional engineer in Alberta, Ontario, New Brunswick, Nova Scotia, Newfoundland, and Labrador. His specialties include civil and structural engineering as well as earthquake engineering. He investigates damaged or under-designed structures, assisting with the review and the design of retrofitting schemes, and conducts structural investigations on industrial, commercial, and residential buildings. Welcome, Nabi. We also have Darren Keel joining us. He's based in Ottawa, Ontario as well. His specialties include remote piloted aerial systems, which is drone operations. He conducts pre-loss and post-loss site inspections, field investigations, and aerial scene mapping. This might be a new term for some of you guys, but we're actually going to be covering what this means later on in the presentation. Darren's responsible for drone operations and training of community safety partners, such as the Canadian Emergency Responders Robotics Association, as well as he is also a flight reviewer for Transport Canada. He is a level 3 traffic collision investigator and a level 4 collision reconstructionist with over 30 years of policing experience. So those are the introductions of our speakers. I'm really excited for today's presentation. We have a tremendous turnout today, and so we're so happy to have you all. I'm going to pass off the mic to Nabi to get the show on the road.
Thank you, George. Thank you everyone for joining us. So in this webinar, I'm going to talk about the importance of forensic structural investigation and some basic concepts in structural design and cause of damage after wind and snow events, safety factors in design of buildings, and drone-assisted inspections, which will be presented by my friend Darren. So I want to start off by the simple question that why is forensic structural investigation needed? And the reason I'm asking this is a lot of times the cause of damage seems very obvious. For example, you see a sagging in the roof after winter, and it seems obvious it's because of the snow. Or you see cracking in the ceiling, and you think it's because of the snow. After a windstorm, the braces get damaged and get broken. It's because of the wind. So they all seem very obvious. You see cracking in the retaining wall after a tornado, and you think it's must be tornado. Now, in most cases, the cause of loss seems obvious. It's just that they seem obvious, but they're not exactly what it seems most of the times. Now, it is important to determine the root cause of damage for three main reasons. First of all, to determine the insurance coverage. And for us, for structural engineers, it's important to determine the required repair and to address safety concerns of the structure. I'm going to explain this in more details in the following examples. But now, I want to talk about some basic concepts in structural design. A structure is designed to carry the design loads that are specified in the building codes. If the loading exceeds those design loads, a properly designed structure will show early warning signs before sudden collapse. A sudden collapse, we call it a brittle behavior, which is not favorable. So a properly designed structure will fail in ductile behavior. Examples of early warning signs are like cracks in the walls or ceilings, or inoperable doors, like if they are stuck in its framing. These are early warning signs that you need to pay attention to. And also, structures are designed to satisfy life safety and serviceability requirements of the building code. And what I mean is, let's say if the ceiling should not fall on your head, no one wants that. That's a life safety concern. At the same time, the ceiling gypsum panels should not crack. That's a serviceability. Or the windows or the doors should be operable. If they become inoperable after some time, that's a serviceability issue. Now, about early warning signs, if you observe early warning signs, the structure should be inspected to see if there are some potentially life safety or serviceability concerns in the building, especially if the house or the structure is an old structure. Now, I'm going to go through some examples and explain some of these concepts through these examples, so you get a sense of what I'm talking about. So you see a roof sag, a sag in the roof after winter, and you might think it's definitely because of snow. And there's no doubt that the sagging of the roof happened under the weight of the snow, but it might not necessarily because of the snow. Maybe it's some structural, constructional deficiencies. Now, at this point, I want to talk about the structure of the roof. So you have the gravity loads here, which are dead loads, the self-weight of the structure, and the snow load. The gravity loads are sitting on the rafters, and through the rafters, they're going to the columns. So the rafters, they're under compression because of these loads, and this inclined compression force at this joint, some part of it goes to the columns through compression. The other part of it creates a horizontal force, which we call it outward thrust force, which is carried by the ceiling joists. So this outward thrust force generates tension force in the ceiling joist. Now, this system is a complete load path. So rafters, ceiling joist, and columns. During a wind event, you have suction on the roof. So then the rafters are going to open up. So this joint is under tension. The collar ties are under tension, and the columns, of course, are under tension depending on the wind speed. Now, so in these examples, you saw the sagging in the roof. We got into the attic to see the problems in the attic. Now, just want to show you the rafters and collar ties in a real roof. So this is ridge board, rafters, and collar ties. These are lateral bracing of the collar ties, and this is bracing of the gable roof. So this is the sagging in the roof in our example. We got into the attic, and we saw some pre-existing construction deficiencies like inadequate splice and undersized rafters. Rafters should always be continuous, and they need to be properly sized. This is the general view of the attic, and we also noticed that the rafters were not aligned in some spots. Also, again, misaligned rafters in some spots and discontinuous rafters. So these are all pre-existing structural deficiencies. The other example is you see a crack in the ceiling after a snow season. Obviously, the crack was formed under the weight of the snow. It's just that we need to get to the root cause of that crack. So we got into the attic. Again, we saw temporary construction struts. As I mentioned, the roof structure consists of rafters, collar ties, and ceiling joists. That's a complete load path. Now, when you put a construction strut, when you put a strut here, that's not the intended load path. These are construction struts. They're just put it there to put the ridge board on and put the rafters on. After the construction, they're supposed to be removed. Otherwise, they cause cracking. And here's the reason. As I said, you have rafters, ceiling joist as the complete load path. Now, if you have a compression strut here, then the loads on the roof, instead of going through the rafters, they go through the construction strut, and they go to the ceiling joist. And this ceiling joist was not supposed to take this load. So that's what we call unintended load path. So the construction struts were supposed to be removed after the construction. So the root cause here was unintended load path and not necessarily the snow. Again, another example, again, crack in the ceiling. So again, these are early warning signs, the cracks in the ceilings or the sagging in the roof. And it's important to do a structural inspection to determine what the root cause is and what the pre-existing conditions are. So in these examples, we saw the cracks in the ceilings. we inspected the attic, we noticed that the original construction had trusses, 2 separate trusses on either side of the wall, and the owner added new rafters and cutter ties. So it looks very a proper structure, as I explained, like rafters and cutter tie. However, there is no continuous seating joist here, or what we call rafter tie. So because this is not continuous, then the tension force that I was talking about before, they cannot carry by these cord members. So that's why it formed cracking here. Now here's the point. When you see cracking, as I said, it needs to be inspected, because to determine the root cause of the damage, and by that you determine the correct repair method. For example, here, if you just replace the cracked gypsum board, that wouldn't solve the problem. The proper repair method was to make this cord continuous. And that's, as I said before, that's one of the reasons why structural inspections are important when you see early warning signs. This is the attic view of the house. So these are the new rafters that the owner added. And this is the crack in the ceiling. So unintended load path again. Because the ceiling joist had to be continuous in a rafter structure of the roof, but that was not the original intention of the roof structure in this example. So when you add rafters to the top of the trusses, the owners had to, or the engineer had to properly connect the trusses together, so you have some continuous rafter tie and ceiling joist here. Now, some concepts about structural design. Snow and wind loads are prescribed in building codes for every city in Canada. And snow and wind loads are based on the maximum probable wind and snow loads in 50 years. And also in structural design, we use safety factors to make sure there's some safety margin in the building, so that if the loading exceeds the design load by a little bit, the structure can still carry that load. For example, a chair, if you want to design the chair properly, you don't design it for the weight of an average person. Let's say you don't design it for 150 pounds, because some people are heavier. So you design it for a higher load. And not only that, you also increase the load by a safety, by load factor to account for safety margin. Now, in National Building Code of Canada, the snow load is amplified by 50%, and the wind load is amplified by 40%. For example, in Sudbury, the ground snow depth, the design ground snow depth based on NBC 2015, National Building Code of Canada 2015, it's 71 centimeters. To design the roof, we multiply this by 1.5, so we add 50% to this number. So if you get, for example, 75 centimeters of snow on the ground, the roof should still carry that load. It should not break. It might deflect more, but it should not break. Now, for example, again, using this table, in Sudbury, this is a design ground snow. The actual ground snow in 2019 was 102 centimeters. So it's still less than 1.5 times 71. It means that if a roof collapsed, if a residential roof collapsed in Sudbury, after a snow, it's not really because of snow. It's because of some pre-existing conditions. The reason is this 102 is within the 1.5 times 71, which is about 106 centimeters. Now, for example, this was a barn. The roof collapsed after a snow season. We inspected the structure. You can see the trusses are coming and sitting on wall studs. There's a wall stud under every truss, and there's a plate at the top of the wall studs, and the trusses are bearing on this plate. Now, if you remove the truss here, this plate cannot take the load because the plate will become a beam then. The owner opened up these big openings without actually putting a beam here. And of course, those top plates failed and the barn collapsed, the roof collapsed. Here's another example of collapse of roof under snow. I asked Garen to help me inspect this structure with drone, and we did an investigation. And the root cause of the damage was actually long-term deterioration of the barn. Another example, the roof was partially collapsed after a snowstorm. And the question here was it the snow or was it the wind or what was it? We inspected and we had the weather data of the day of the loss. We had the wind direction, wind speed, we calculated snow accumulation here, and we found out that the root cause of the collapse was combined effects of snow and wind. So in this case, the loads were actually the root cause of the collapse. So sometimes the root cause is pre-existing conditions, and sometimes it's actually the load. So it needs to be investigated. This was a 30 feet by 180 feet long barn under some windstorm. The braces broke, and we checked the design load, the design wind speed. It was 91.8 kilometer per hour, and the actual wind speed was 98 kilometer per hour. So it was obviously 98 was more than 92 kilometer per hour, but it was still within the safety margin. So if this barn was designed properly, the brace should not have broken under this wind speed. So there was some other pre-existing issues here. And the issue was that there was not enough bracing for this long barn. It was just 2x bracing at both ends of the barn for a 180 feet long barn, which is not enough. Another example, the cladding was blown off during a windstorm. And again, the actual wind was 82, the design wind was 84. So the actual wind speed was actually lower than the wind speed. We investigated, we figured that the fasteners, they were just screws that were withdrawn from the wood girts. So that was an insufficient fastening of cladding to framing. Because for cladding, when you fasten it, it should be properly fastened to a proper backing so that it doesn't get withdrawn easily by wind. We also, during that investigation, we also spotted some other pre-existing construction deficiencies. This is a discontinuous joist on the roof of that shelter. So the true cause was, again, pre-existing construction deficiencies. Another damage to a house, to the door trim of a house. This was during the tornado in 2018. the claim was that this gap happened because of the tornado. And we investigated, and we found signs of soil settlement under the garage. One was the flashing pulling away from the exterior wall of the building, and also the gap was narrow at the bottom and got wider at the top, which was a clear indication of some sort of rotation of the garage because of the soil settlement. So in summary, extreme snow and wind load conditions, depending on their magnitude, may or may not be the root cause of the damage. The true root cause of the damage might be, in extreme cases, might be actually the loads. But in a lot of cases, the root cause is pre-existing design and construction deficiencies, non-engineered alterations, unintended load paths, and long-term deterioration. And it's very important to determine the root cause, so that first of all, to determine the coverage, but more importantly, to determine the proper structural repair and to prevent major failure in future. Now, with that, I want to pass the mic to Darren for the exciting part of this presentation. Darren?
Hi, everybody. We've got a great turnout. Thanks for coming out, folks. Okay, Nabby, yeah, I'll just follow your lead on the drone. What we're looking at here was jumping right into it, a barn inspection that Nabby had. We showed the overhead earlier, and we're just going to play. It was unsafe to enter the barn, so we were able to put micro drone in and successfully fly into the structure and inspect the areas that were needed to be looked at by Nabby. We integrate this the investigation or the inspection with the structural, either on site or off site, but he's seeing the same data I'm seeing. So he'll, in this case, Nabby would tell me where to fly, what to look at, so he could make notes, record, and capture the data that was required. And it was very successful because this was an area of the barn he was not able to enter into.
That's right, yeah.
At any time, yeah, absolutely, Nabby. So this one was a recent one here in Eastern Ontario. It was a collapse, a roof collapse, and Nabby was not able to get up into the rafters on the structure. So we were able to put a small drone system up into the area. We fly very slow, illuminate the area, and we very much work as a team with Nabby, directing me where to fly, what to look at, and then he's able to collect the data that he requires.
Yeah, if I may add, it's when there is unsafe space and we cannot, or confined space or unsafe space, and we cannot see the pattern of the damage, we cannot really determine the true cause of the damage, because it's very important to get visual of the broken pieces and the pattern of the failure to determine what's happening. Yeah, Darren.
Yeah, absolutely. And keep in mind with a lot of these, what you're seeing here, across the board, you're seeing a lot of drone companies popping up and offering you services. What we bring, and it was mentioned in my bio, my background is policing, and we train tactical units to fly in confined areas. So although somebody may own a drone company, they're certainly not going to be flying this level interior and being able to gather the data. That's where we have a leg up, I believe. In this case, this was a structure fire down in St. Catharines, and we were able to get up very danger close. I'm flying very slow. I'm able to work with the engineer and get to the beams and the rafters, and these are all metal, obviously, and inspect them so he can collect the data for his report. And that's what we're doing. We're collecting the empirical data required for the structural to make his assessment at the scene. And it's very much a synergy between the drone operator, myself, and or other pilots we have, or and the structural.
Yeah, this is a confined space. Yeah, an example of the
right,
inspecting confined space. Darren.
Sure. So in this case, instead of sending in the engineer or the inspector beneath the structure, we fly down through there. I've got a limited space, about 24 inches, if I can get it that much. then I can get a drone into it, illuminate the areas of interest for the engineer, and gather the data. So this is not a handheld camera. This is actually flying, and I flew it in where Navi didn't have to crawl. So that's the paramount difference here. We're trying to put a system in and gather the data and keep safety at the forefront. So by doing this, we can pretty much put any of our systems anywhere and get the data that's required without putting the engineer at harm's way.
Again, and you can see that easily in these crawl spaces and basement and roofs and confined and high altitudes. You can quickly gather a lot of photos and videos and spot the failure points or the deficiencies. It's like all this inspection took like 10 minutes or something for this under the deck. Yeah.
Great. And we pre-plan, obviously. So in this case, Navi wasn't on scene, but I was able to go down to Southern Ontario and gather this data for him and remote live broadcast. So if we have an adjuster or client that requires, that actually wants to see it, you don't have to be on scene with me. So from this location, I was flying both interior and exterior of this barn at altitudes and gathering the data, and at the same time live broadcasting back to Navi in Ottawa. And in the case, if it was an adjuster that had to be seen, we could link you in on our live broadcast. You'll see exactly what I'm seeing with the drone in the air.
Yeah. So this is
another crawl space example. Being able, so you can see how much space I have there. So if it's a structure that's hazardous, it's dangerous, you can't get into it, or a basement, attic, as long as we can get some light into it and illuminate the path, which we have remote lights, then we're good to go. So it is very, very technical flying. We do it very slowly, and there's a synergy, again, I mentioned, between both the structural, in this case Navi, and myself, to get in close to the ties and look at what he needs to see.
Yeah, and I need to emphasize that using drones in inspections where needed, it saves a lot of time, because like for me to crawl in like a big crawl space, like it takes a lot of time. And how much photos can I take? Like how many spots can I crawl into? Like, but with drone, you can see the entire crawl space very quick within like 10-15 minutes, and that's it. And gather a lot of valuable data that you can then process to see the damage or anything.
And one new little trick we've been learning and been experimenting with is, we'll see it a few slides ahead, a panorama 360 of an exterior of a structure, but I can do the same thing to an interior of the structure. I can get a 360 rendering that's interactive with the client and provide that data also.
Yeah, let me show you some panoramic. Oh, here, yeah. This was right. A fire loss, yeah, in a multi-residential building.
Yeah, this was a multi-million-dollar loss. So Maslin had me come down to Southern Ontario and get the data. So as you can see, ground data is good, obviously, as an investigator, but the aerial data also can give you burn patterns, especially on large losses, something of this nature, and give you an overall scope as to the loss that you've had at the scene. So in this case, I was able to brief with both structural and mechanical at scene and get the data that they required, and it was included in the brief of the final package.
Yeah, and fire investigators. So our drone service is not just for structural, so it's for any discipline. So for fire investigators, for mechanical, so anyone who wants some visuals from high altitudes, confined and hard to reach spaces, they can call Darren for drone assisted inspections.
Right. And what we're able to do, a site like this, we're literally taking a snapshot in time, because once the cleanup crew comes in and it's gone, your scene is gone. So it's imperative to capture the data you need, especially if you have to go back and look at something later. If you haven't caught it all, then it's gone. But from the air, we certainly can do this. You want to just explain what we had here, Nabi, and I can talk about the map.
So this is another example of one of our files. So we did the mapping here. First of all, for me to get the site plan, and also for me to get the exterior dimensions of the house. It's amazing, like all this was done like in 10 minutes, and the drone was in autopilot mode. Is that right?
Yeah, and I can just mention that. So basically the technology you're seeing here is, with my background in policing and collision reconstruction, we've introduced drone mapping in conjunction with robotic total station at scenes in policing over the last few years. You're now being able to see it here in the private sector for civil litigation. So I'm using the exact same technology that I've done there, and I have used this technology here to do collision scene analysis reports for origin and cause as a collision recon.
Yeah.
And we have multiple staff. So,
and if you notice,
go ahead, Nam.
And if you notice, like on this map, like with the software drone deploy, you can just cut any path through any like structure or anything, and you can see here, for example, you can see the slope of the roof, the difference in elevation between the roof and the ground. So that's technically the height of the house, and also the same way you can draw another path, let's say, to get the exact dimensions of the house, and also the same way for the site plan. And of course, the same thing you can use for large losses if you want to see the extent of the damage for commercial buildings. Yeah.
We talked about that in the past, such as explosions or fires. You can actually see burn patterns, debris fields, etc., from the air versus the ground. The perspective is completely changed. This is a large loss fire up in Ottawa. Yes, Ottawa. We were able to put it up. We're flying close to an embassy, towers. With my license, I'm able to get flight authorization to fly in those areas as well.
Yeah. So this is an example of the large loss in Bahamas during the hurricane.
This is some. I was flying for the Civil Aviation Authority for the Bahamian government, November 2019, on an island called Large Abaco. So my tasking there through a global nonprofit was to map many acres over almost 3 weeks. We were able to provide these maps and the data, and they were able to provide this to insurance adjusters that were down there. So again, taking the skills that we've learned up here from police doing recon mapping and site mapping, it's the same thing. So it was an invaluable tool that moving forward, we're looking at this for our CAT teams and expanding in that role.
Darren, how long did it take for you to take this map, for example?
That map, you're looking at about probably 5.5 acres. That was a 25-minute flight.
25 minutes and 5.5 acres.
Right.
Yeah, it's amazing.
Right. There's no other way to gather this data. You can't do it with a helicopter, not to this level. The costs, you're just not going to have a helicopter in a zone like this. So it's just replacing those types of technologies.
And I see that the zooming capability of the drone is great. Can you speak to that? Like,
yes.
The zooming. Yeah.
Right. So it's depending on the lens on the aircraft. So you can use, say, a Phantom 4. You won't get this type of resolution. This particular drone I flew was called a Matrice 210. The optic camera on it had an X5 camera. The cinematic drone we use for origin and cause, one of them is an Inspired 2. The lens on that is unsurpassed. So the details, it really comes down to the lens and the camera that you're using on the drone. We have an extremely high-end system, or several extremely high-end systems. That's how you capture the very high resolution and the ground sound distances.
How's the accuracy of these dimensions, Darren?
Yeah, on this map now, without putting what's called tie points in, or where we use robotic total stations, you're within plus or minus probably 10 to 20 centimeters. So it's not survey grade. For that level, we would have to include tie points and GPS robotic total stations ground control points, but for quick information and data that's required, this is certainly sufficient.
Okay. And yeah, so let's get back to the, because we talked about, yeah, so the thermal imaging.
Right. So what we've seen, we've used extensively for search and rescue missions within law enforcement. We've now brought that technology over here to origin and cause. If we can detect water penetration through heat loss, it's a good way to use the thermal camera. Very sensitive. As well, what we can do is map a scene in a thermal in a thermal spectrum. So what you saw was the RGB spectrum, so the red, green, blue photograph. In this case, I can map a site to see heat loss and water penetration and use that if we're doing a building inspection as well. So it's very useful, certainly in the wintertime as well.
Yeah. And I guess we kind of talked about these. So you're licensed to fly across Canada, right?
Right, I can fly anywhere in Canada. I've even flown in Trenton, Ontario, under the flight path of CFB Kingston or CFB Trenton, sorry. So it's just a matter of having the right pilot certificate and authorizations. But anywhere in Canada is basically an operational zone for me. This is some of the systems we use. This is a great little workhorse, this thing in interior, Mavic Mini. Good flight time, gets the resolution that we need. We slap prop guards on it, we're good to go. Go ahead, Matt. Nab, for time.
So question. So what's the operating temperature for Mavic Mini?
Right.
So is that during winter time? Are you limited to use this system?
Now it depends. I mean, that's what they're going to recommend. So if you lose the drone, it will fly below that. I've actually flown that down -10, -15 degrees Celsius. But as far as the manufacturer specs, that's what they're going to allow you to. So if you lose the drone, you won't be. As far as your insurance, it's not going to replace it. So
yeah, but you fly it, but you have flown it with -15 as well, right?
Yep. It just drains the batteries faster. This is the Inspire 2 that I mentioned, X5, X7 camera on it, high resolution, 27 to 30 minutes flight time, down to -20. Again, I've flown it cooler than that, but again, you want to be careful, but has self-heating batteries as well. The Mavic Air 2, same idea. -10 is the operating temperature, but it'll go down to -10 or -15, -20. This is a Parrot and Naffy. What I like about this small interior, these micro drones are great for the interior inspections, by the way. The camera pivots up 90 degrees straight up and straight down, and has optical lossless zoom, so we're able to really zoom in on areas in a structure as well.
Yeah. Thank you. And as I said, so our drone services is for different disciplines, and sometimes even you don't need necessarily a structural or any investigation for now. You just need some visual. You can ask us, and their end will be there to help you with drone inspection.
Right. If there's any questions, certainly as to what we can use it for, you can shoot me an email, and without any cost to you, I give you an idea as to whether it will be useful or not. But we're certainly seeing it picking up and being used much more in the field. So looking forward to continue expanding on the program. And we have a great support from Mazen and Mario here in Eastern Canada. So we're looking forward to flying a lot more.
Yeah. Thank you, guys. Thank you so much. Great presentation. I want to encourage everyone to start sending in their questions now for the Q&A. We have several questions that have been submitted. While you guys are putting those together, I wanted to talk to you briefly about an upcoming webinar that'll be taking place in March with regards to the topic of shoring, the rules of thumb and common mistakes. When a property is structurally unstable due to an insurance claim, such as a large fire or any other event that compromises the walls or the structural members of a building, contractors are often required to install shoring so that they can prop up the building and make sure that the repairs can be done in a safe manner and obviously in a cost-efficient manner. Now, it looks pretty simple to put together. It's just a few pieces of lumber, but believe it or not, we see a lot of instances where shoring is not put together properly. And as a result, it causes catastrophic damages. A lot of times the shoring can fail, and ultimately whatever it was supposed to prop up starts to sag, starts to fall, and this causes tremendous amounts of damage and costs for insurers, also liability exposures to contractors and even folks who get injured. So we're going to be talking about this topic. I'm very excited about it because it's something that just seems so simple and is very commonly seen in claims. But I think there's great opportunity for adjusters, for contractors, for lawyers to understand a little bit more about shoring, what it's used for, when it's used, and kind of the fundamentals of how it should be constructed. So I'm really excited about this because I'm excited to learn about it too. And so we're also going to be talking about the most common shoring mistakes that we encounter in the field. So, you know, it's not just going to be technical talk. We're going to be going through stories and case studies to kind of tell you the do's and the don'ts. So just wanted to kind of give you guys a heads up. Once you close the webinar window, you will be asked if you want to sign up to this webinar, which will be taking place March 17th. And you have the opportunity to attend that 1 hour free webinar. So let's jump back to the Q&A. First question, which I believe would be for Navi. How often is such damages in fact caused by snow load? So I imagine that they're probably asking, you know, when an insured reports a claim where there's new cracks found after like a snowstorm or whatever, how often is it actually due to snow load percentage wise?
To be honest, from my experience, maybe 10%. And I should mention that especially if you see a damage, either a sagging or a crack in an old house, like an old house, but I mean before 1990, that's a red flag. Maybe there's some construction deficiencies, maybe there are some other issues there, pre-existing issues there. Also, if there are houses that there have been a lot of extensions or renovations, you know, expansions to the house, that happens a lot. Again, those are again red flags. You might see cracks and sagging there, but the root cause might be something else. So I recommend have those properly inspected, because beside the coverage issue, it's important for those houses to be repaired properly. Otherwise, I guess I forgot to mention, the early warning signs of failure, if they are neglected, in future it might turn into a collapse and some more damage, and potentially endangers the safety of people there.
Great, thank you, Navi.
Yeah.
Next question. Are you able to fly a drone in a flight path around airports?
Yes and yes. So what that requires is a coordination between Nav Canada. So an application is made by myself with my advanced rating. So I have the highest rating you can have for drone operations now, but you still have to operate. So anywhere in controlled airspace, and that would be such. I make that application, and it usually takes anywhere from 3 to 12-hour response, but they're quite quick at it. So I have to make the parameters of flight altitude. The lower I fly, the more the quicker basically they approve it. So that's not an issue.
Excellent.
Yeah, and to that, I've flown in the flight path of like CFB Trenton while Hornets were doing CF-18 Hornets were doing approaches, and it was just a coordination with the tower. So I manage all those permits and authorizations.
Thank you. So there's next to no circumstance there and that you would not be able to fly. Is that right?
Correct. And basically it comes down to coordination with Nav Canada, who basically they own the airspace, contrary to, I believe, Transport Canada makes the rules. So it's knowing the job, making the correct application, and they're very good to work with. So it's just a matter of giving them the exact information they need. And if there's any glitches, we work back and forth until the authorization. But to this date, I've been doing it for 2 years with the new regulations, and I've had no issues.
Okay.
I have a follow-up question on that, Darren. Is there any cost associated with that application?
No, and that is a great question. It will be all included as far as permits and applications. That's included in the hourly rate.
Okay.
So that's done ahead of time.
Yeah.
Thank you, guys. Next question. With cat season only a few months away and the pandemic still an ongoing concern, will drone services help with structural assessments if interprovincial travel is somewhat limited?
That's a good question. Yeah.
Yeah, I believe we're deemed an essential service, so the answer would be for us, no. We've been traveling at this time, and if it's deemed an essential service, I know we've reached out to Montreal. That's not been an issue, but to our knowledge at this point, no. The answer is no.
Well, the question is not if our work would be impacted, but will drone services help with structural assessment when kind of people aren't allowed to travel to different provinces?
Well, absolutely. Well, if I understand, is it about like, can we go to the scene to do the drone inspection, or?
Yes.
I would say definitely, because like we mentioned and touched on, if the adjuster can't get in or somebody can't get in who's non-essential service, we still can, and we can remote broadcast, and it's been extremely successful. So any person of interest on the file would be able streamed from the drone and see exactly what we're seeing. So most definitely it would be advantageous because we can remote broadcast from a site. So we've seen the advantages obviously with structural, and we'll continue pushing forward. So yeah, we discovered a good way to remote broadcast, and it's been crazy successful.
Yeah.
Great.
Also, I need to mention that we are also expanding our drone operation. So in Western Canada, we will be having new drone operators. So for sure, like if you need some assistance with drone inspections, contact us. We can help you with that, either from someone within the province or outside the province. We'll find a way to, yeah.
Yeah, actually, we've received maybe 5 or 6 people asking, is this service available across Canada or just in Ontario for origin and cause? So the answer is, give us a shout and we'll connect you.
Yeah, absolutely. I have contacts from my network right across Canada. So in short, the answer is give me a call, and I can make it happen for you. Absolutely. And we've already reached out to partner pilots out in those regions. So we're good to go if that's an issue. Not a problem.
Great. Next question. Have you experienced any admissibility issues with respect to aerial pictures?
That's an excellent question. Coming from the policing world, the Private Information Act, the Privacy Information Act of PIM, it's always been an issue. So the transparency, now when we're on a site, we're authorized to be at that site. So when I'm flying, I'm not flying to fly and photograph the neighbors next door. It is prudent, and this works quite well when people have questions, and they may come up and ask, are you videoing or photographing my location? That's just a heads up to them. But predominantly when we're on a site, we're authorized to be there flying, no different than a ground photographer who's doing an investigation. So I'm just an aerial photographer doing the investigation on the target location versus anything else. So I'm very focused on the location versus beyond the borders or the property borders.
So have you ever been in a scenario where photos or videos were not admissible in court?
No. They're again focused, and we've been working with in my other job, which I've retired from, policing, and we did collision reconstruction aerial photography. The Crown attorneys absolutely loved the information that we were presenting. They know what we're presenting. So as far as inadmissibility, I've not crossed that path yet. If it does come up, we certainly have the answers that the data we're collecting is for the investigation at hand.
Okay, great. Next question. Do you ever invite adjusters or clients to your drone examinations? I'd love to be a part of an examination.
Absolutely.
On
Yeah.
my files.
Yeah, I absolutely have no issues with it. I'm very focused when I'm flying, and on several occasions, work kind of stops when you do fly a site, because we're not just taking shots overhead. We can be flying down into the building as well, and collecting that data, and lots of questions get asked. That's pretty much been on every scene where there's been other investigators. So without a doubt, I can facilitate that, and love to show you what we can do.
So the client can actually just be sitting at their desk, and through a browser of some sort are able to view what you're viewing and communicate with you. Is that right?
Yeah, so the best way we do it, it could be Skype, Teams, whatever platform the client might have. But if it's prearranged, as long as my boss doesn't have an issue with it and they're part of the investigation, yeah, we could link that individual up to see exactly what we're seeing. And that might be a high overhead flight, part of the mapping, shared screen, or actually flying through the building.
If I may add, so the files that we did Skyping, it was very seamless, very convenient. So there were files I could not be unseen with Darren. So if he broadcasted, I could see it seamlessly. I actually took some photos from my screen just to use for my investigation. And I guess in this presentation, you saw a couple of those photos, the ones with crosshairs. So those ones were the ones that I was Skyping with Darren. And in those calls, you can invite the adjusters and anyone who wants to be part of that investigation. That would be a conference call, and it works very well. Yeah.
Fantastic. Okay, next question. Can hailstorm damage the concrete structure, like cracks in a stucco building or cracks on the driveway? If yes, what possibly can happen to a concrete structure?
During hail?
Yes.
Like during hailstorm? Well, that's a very particular question. It's very rare damage to concrete, but it needs to be, depending on the event, depending on where it is and how it is, it needs to be inspected. And cracks per se, I would say it's very rare. It probably might be something else if it's a long crack or something. And to be honest, I've never heard of crack in concrete because of hail. So yeah, so if there's something like that, it needs to be looked into to see if there is some other issues like settlement or underground water pressure, depending on where that condition is. Probably settlement. Yeah, it needs to be looked into. Yeah.
Okay.
Yeah.
Excellent. Thank you. Well, we've hit our time. So we have several more questions that have been asked, and for all those folks that have submitted their questions, we will be following up with you in email form after the webinar to make sure that we get to you. Thank you all for joining us. We will be sending you a completion certificate within the next week. So please keep your eyes open for that. And we thank you so much for joining us and hope that you'll join us for our next webinar on shoring. Thank you all and stay safe and have a great day.
Thank you, everyone.
Thanks very much.